thank you for coming to PyData Global 2021. Well, we're here for Gus Gus's talk, and since this is time, I'll hand it off to him.
Thank you so much. Share my screen to everybody. So just if you're here, this is, let me find, high performance Python with Numba. I think looks like we're about 45 to 50 minutes behind. So we're in this break period. I'm gonna try to catch us back up. We're gonna go real fast, which is fitting for high performance Python. And so if you're coming in for storytelling with data, we may just be a little bit delayed. So let's get into it. So I have a couple of quick slides, and we're going to go really fast. So the expectation for the absolute beginner is that you may know about Python. You've heard about it, and if you have, that's good. It's very popular. This is PyData. I assume you've heard about it. But you've heard some things about Python. You're interested. You want to make it go fast. Let's get started. So let's jump in to our first example, because people will often say that Python can be slow. So I'm going to come over here into a Jupyter notebook. And what I'm going to do is I'm going to fake a scientific workload. So we're going to go, apologies, we're going to go real fast, throw your questions and other things into the chat. I'll try to monitor as best I can. Oh, the other next talk is on a Zoom URL. Thank you so much for telling me that. We will go a little bit over then. Great. So what we have here is a fake scientific workload. We're going to use numpy, and we're going to basically pretend like we're gathering some image data from some sort of detector, from some sort of sensor. We're going to smooth it, so we'll average the input points. And we just have this for loop here that's kind of Fortran style. It's basically, this is some sort of numeric kind of quantitative method. We're going to run this thing, and at the end of this, we'll just pretend like we're saving something. So again, this is fake. It's just meant to be illustrative. We're going to run this with numpy and with pure Python. Oh, let me refresh. Or let me run this again. And this is going to execute in about 10 seconds. And so as we're just looping through here, running this function gather from detector, creating this fake array, we're doing some smoothing. Again, just generic Python stuff. Gosh, maybe it runs here processing 5 fake images in about 10 seconds. Maybe that's good enough, maybe it's not. But the question is, can we make this faster? And our first tool in the toolbox to do so is we're going to introduce something called Numba. And Numba brings us a JIT compiler. This means it's going to take our Python code, it's going to compile it. We can now get closer to C, C++, Fortran-like speeds. We'll never exceed those, but this is still Python. And what's really nice about this, and I'll go ahead and run this really quickly while I talk about it. What's really nice about Numba, and it's going to be a very cursory explanation here, is that this is a just-in-time compiler. So if you've heard about Cython or if you've looked at some things with C, you need to specify ahead of time what your types are going to be. With Numba, we don't have to do that because it's just in time. So I wrap this little decorator, this is one convention for using Numba, around my previous function. I don't change anything else. Of course, also I import Numba. So I import Numba, I wrap this little decorator, and now when I run through those same 5 fake images and process them, it runs much faster. So we went from approximately 10 seconds to 700 milliseconds. And in fact, most of that was compilation time. So when I run this again, it's even faster now that the code has been compiled. You can see we're getting really low latency. So kind of first break, right, before we even intro and get into other things, hey, if you've got some for loops, if you've got some numpy arrays, if you've got some things where you might want to broadcast a function across them, Numba is a really interesting tool to check out because we can compile our code. We can get C, C++, Fortran style performance. We don't have to, we can do it very simply for getting started. There's low penalty here for getting things wrong. Now, Numba isn't applied everywhere. There are use cases pro and against, but just as a quick kind of carrot, hey, check this out. This can be a really useful tool. With high performance, we got to go bigger, right? So we did 5 images. To continue this example, let's do more. Let's do 10x the number of images. And when we run this, same thing, we're going to, as again, these images are fake, but they're meant to be kind of a realistic example. This takes a little bit more time, 4 seconds. And as we scale this up to 500, we'll see some linear scaling, 5 seconds to 18 seconds. So we're starting to hit maybe a bit more of a performance bottleneck on this machine, on my local machine here where I'm running this Jupyter notebook. So let me jump back as an example here. Sorry, let me go back to my slides. So we went through this. Hey, we took our Python code. And I'm sorry, I got a little bit discombobulated, but our Numba example took us from slower Python code to faster Python code. Now, the reason I'm here, the reason I want to talk to you, my name is Gus Cavanaugh. I used to be a consultant. I worked on some data projects, small and big. I've got a 3-week-old kid, so I'm a little bit out of it. And what is, I think, what I like, or why I'm here is when I first got started working with Python, working with data, I struggled with a lot of the tooling that was around, hey, I want to analyze some data. I've learned a little bit about, let's say, pandas, but I'm struggling to actually get this installed, get everything figured out, make it actually work. And as an example of this, when I started my first kind of Python job, I didn't know what SSH was. And so I would walk to the server room. There was no cloud. This about 10 years ago. I would walk to a physical server room. I would pull the little rack-mounted appliance out, and I would work on that little appliance in the server room. No one else was in there. I didn't know any better. And eventually, I only learned that I wasn't supposed to be doing this. My boss was like, "Why aren't you at your desk? You don't have meetings scheduled. What's going on?" And I was like, "Oh, I'm working on the server." And they're like, "You need to understand, you need to be able to, you can remote access the server." So this is what I say for the absolute beginner now, as I'm trying to intro this talk. This is what I mean. Like, I understand there's this concept, like I've got some Python, I've got something I can run locally, but help me make this work for me and show me all of the steps in between. Don't leave anything out. So that's what we're going to do. And so my kind of expectation here, hopefully with that kind of quick Numba example to kind of wet your whistle, is you are interested in PyData. The PyData stack is extremely popular. That's why we're here. Pandas, NumPy, Matplotlib will include scikit-learn, a bunch of other packages. But they do struggle a little bit here. Or I'm sorry, why do we like them? They work, they're easy. Most importantly, they are free, but we're going to hit some of these scaling issues and we're going to hit some of these speed issues. So what we want to introduce next as we move into, okay, I've got a pandas data frame. The next big tool to make this go faster is going to be Rapids. So we're going to go back to our notebook now and we'll explain what Rapids is and how it works. So I'm going to jump over here for a second to a different Jupyter notebook. This one's actually running in SageMaker, and we'll go through all of that a little bit later. But now I've got my pandas data frame, and I'm going to read in this kind of canonical pseudo big data set, this New York City taxi data set. Everyone's probably super sick of it. But we're going to go ahead and read this in, and we're going to perform a group by using pandas. And this is going to take about 20 seconds to run. Now, again, that may be good, that may be bad, but we can make this faster. And with Rapids, what makes Rapids so interesting and exciting is Rapids is going to extend the PyData stack for the GPU. So here I import pandas with pandas convention as PD. I read CSV, I run a group by, it takes 20 seconds or so. Let's use a part of the Rapids package called cuDF. I import cuDF, I run cuDF read CSV, and I run a very similar identical group by, and this is going to execute much, much faster. Now, oh, memory error, how fun. Let's restart the kernel. So this is supposed to be my next example. I've somehow gotten ahead of myself, but let's run this one more time. So we'll restart this, we'll execute our read CSV. And so what we're doing, and oh my gosh, I'm embarrassing. So what I wanted to show you was this was going to execute in about 8 seconds. And the core idea being that, we'll come back over here very quickly to some slides. The core idea being that thanks to Rapids, this package that came from the good folks at NVIDIA, we can take our pandas code, we can import cuDF, and we can run very similar code. We'll also be able to do the same thing for NumPy, for scikit-learn, for other packages. But I want to show this pandas example with cuDF. However, what can happen and what will often happen is you can get these memory errors, specifically because well, for one reason, because the GPU memory can be slightly different than the CPU memory available on your machine, in my case, on my SageMaker instance. However, what I was hoping to show was that we would get this memory error with a larger data set. So in this case, reading in this single file, this one has about 7 million records. It's not that big at all. The GPU was going to be faster, but significantly faster, meaningfully faster, worth the money faster, questionable. So in this case, this will definitely show a memory error when I read in, and forgive the ugly code, But when I read in the entire year's worth of New York City taxi data, which is a larger data set, so 7 million times 12, 84 million records, we hit this memory error. And this is very common. And so this made me think of like me walking to the server room. Like this is the kind of thing where as a user, I get stuck here. And there are ways of thinking about how you should profile your code, how you should think about high performance code. You should absolutely read this book by Ian Oswald, and I won't pronounce the other name. I've read through the chapter on Numba. I clearly haven't read the whole thing, but this will give you the actual like, hey, what's the computer science approach to this? How can I do this really intelligently? What I'm trying to solve for here is like, I'm getting stuck with this exception. What do I do now? And I really want to stay just within this basic API. Don't make me think too much. Don't make me understand too much. And so what we're hitting at this point is basically we've got enough data where even though we have this really fast GPU, now we can do these, our compute is just, that's created a memory bottleneck. So let's go back to our slides really quickly. And basically what we've seen is, and this is, does not scale. GPUs will often lead to memory bottlenecks, very similar with pandas. And in fact, with that data set, reading in all 84 million rows on my small SageMaker instance, that too would have caused a memory error. So I will now say, okay, great. We have to scale to a larger data set. We want to use the GPU. How do we do this? So we started with, I've got some Python code. I can use Numba to compile it, to accelerate it. I then went, okay, well, I've got this pandas data frame. What's the best way to accelerate that? Something like Rapids, cuDF runs on the GPU. But now I'm stuck, because now it's not fitting in memory. I've got my compute running fast, but I'm stuck on memory. And so if we go to just a random person on Twitter, I don't know this person, but from a couple of weeks ago or from the late summer asked, what's the best way to read a 100 gig file? And the Twitterverse responded, read the file in chunks, more RAM, you should download more RAM, don't use Python, pray. You get lots of fun responses, right? And somebody, a very helpful, a good Samaritan responded, I'd recommend you use Dask. So what is Dask? What is this thing? Dask is a Python package, part of the PyData stack, that allows us to scale arbitrary Python code. It has two levels of API, or two basically interfaces. One is for data frames, arrays, scikit-learn style estimators, and it will scale these across multiple cores or across multiple machines in a cluster. This is going to be very helpful for getting us around our memory bottleneck. We'll be able to more efficiently use all of the cores on a single machine, all the memory on a single machine, or, and in this case, and all of the nodes in a cluster, which we'll get to in a second. Now, Dask also has a lower level interface for arbitrary task scheduling. We won't cover that today, but you can do a lot. You can build on this a lot. This is foundational for a lot of other libraries. So what often happens in Twitter, right? You make a suggestion, you try to be helpful, someone's going to shoot you down. So this guy says, no, you don't use Dask, you use PySpark. And so as we're now moving into the Dask section of this, this is the analog you'll see outside of the Python world is, hey, use Spark, use PySpark. Sure, it runs in the JVM, but you have this Python interface. Dask is very, very similar. As this person points out, it's also distributed. And the idea here is it's the familiar API. You're going to be very, very close to the Pandas API, just as cuDF with Rapids is very, very close to the Pandas API, so that we don't have to learn something new, which again comes back to kind of my fundamental point of or motivation from starting this is please keep it as simple as possible. If I can run something in Pandas, help me run this now faster, help me run this with more data. Okay, not just random people at Twitter, but real companies, organizations use this. Walmart has a great example of using, down here at the bottom, you can see some of the logos, Rapids and Dask together to do in-store forecasts. So they have to do these 500 million forecasts, all of these combinations on year-long horizons. It's this monster problem, this big simulation. And what they were able to do with Rapids, with Dask, XGBoost has a native Rapids integration. So they're able to reduce this processing time down so they could get it within a 12-hour window, because it has to be done every day. So they can't get it done in 12 hours. It's no good to them. They're able to make this work. I have no idea how this is running for them with all the supply chain woes of late. So I won't comment. This is a little bit older than that, but I think it's a good motivating example. So we've got kind of random people on Twitter saying, hey, Dask Rapids. You've got companies like Walmart, hey, Dask Rapids. Let's put it together and jump through our example. And while I switch back here, I'm just going to check quickly in the chat. Okay, good. So we got some questions about how easy is it to get Numba set up. Excellent. We will get to the setup here at the end, or not at the end, but after showing this next example with clusters of machines. So I'm going to switch from SageMaker now over to Google Cloud Platform, Vertex AI, but basically just a hosted Jupyter Lab instance, running all of these same examples in each environment locally in the different clouds. And what I want to do now is I want to install Dask. And I'm going to use cuDF again. And this is that same code we ran before. And when we ran this, it took 8 or 9 seconds, but we want to run this with everything. And when we ran with everything, we got a memory error. So how do we get around that? Well, introduce Dask. So there, Dask, we will import, the Dask distributed client, as well as this local CUDA cluster. And in the interest of time, I'm not going to explain what this is at the moment, but I'm just going to instantiate this. I'm going to create this local client. So what this is going to enable us to do is more efficiently work with the resources on my, in this case, client machine, which is this GPU instance, very modest GPU instance in Google Cloud. It has 4 cores, 16 gigs of RAM, and 1 T4 GPU. And I can see that right here in this local CUDA cluster. So I've got my 14 gigs, I've got my GPU in here inside of, it should be here in this worker. Here's my GPU worker, Tesla T4, which is like a good combination of performance and cost. This instance I'm running costs something like 38 cents an hour to run, and I'm paying for this, so I want to keep the cost down. And now I can go ahead and execute but very similar code using Dask cuDF to read CSV and perform my group by. Now, in the interest of time, I'm not going to run this, but I'll just show you the wall time from calculated earlier. This now takes 3 minutes. So let's contrast with previously it was, hey, we ran this group by, or we were trying to load all of the data, even read the data in. We're getting memory errors, CUDA errors. Hey, you don't have enough memory on your local machine or your client. Now we can execute this. So this is probably going to be another good flag in the ground for a lot of people here. You pip install Dask, and we'll get into the installation steps. It's very straightforward, but you can use Dask locally on your machine, on your laptop, workstation, wherever you are, and you're going to be able to get around a lot of memory bottlenecks. This is especially useful for the GPU workflows, for using rapids, for using Dask cuDF, because it's more likely that you'll run into those, and with Dask, you'll get around it. Now, 3 minutes isn't necessarily barn burner fast time, right? Like we're not lighting it up at 3 minutes. And this is a PyData talk. I've got 30 minutes. I want this to be fun. I want this to be high performance Python. So let me show you some examples of using Dask now on a distributed cluster. So in this example, and I hope this is big enough, I'm sorry. In this previous example, we had Dask running on a local machine. Now I'm going to have Dask running on 4 workers. And I'm going to use a tool. I'm going to use a piece of software called Coiled. This is a company. I work for Coiled. I'm a salesperson for Coiled. So this is not a Coiled sales pitch. It is just an easy way of getting Dask clusters in the cloud. There are a bunch of other approaches, and I'll cover those at the end. But suffice to say, once I have this cluster with my workers on it, let's just make sure this is still up. Great. I've got a cluster, 60 gigs of RAM. Each of these is composed of essentially my same CPU client instance, 4 virtual cores, 16 gigs of RAM. Now I instantiate my Dask cluster just as I did before. And when I execute this, it's going to run much, much faster. Now note here, or as an aside, I'm jumping back from the GPU. I should have maybe been a bit more explicit here. I'm just using CPU workers. And I can come over here and take a look at this and see what's going on. So this is a Dask dashboard. This is available regardless of how you deploy Dask. So you're seeing it inside of the Coiled interface, but this is the same if you run it with a purely open source. You'll have this nice dashboard, and you'll be able to see your task stream here, all of these tasks running across the cores in each of your workers. And this will execute in about 2 minutes or so. So we're getting an improved speed up from our single GPU, from running Dask on the single server, from running our local CUDA cluster. But it's still not running as fast as I'd like for a talk like this. Like, we're getting better, we're getting performance. I could add more workers here. I can now start to linearly scale, or I could solve for this problem. Is like, how fast do I want this to run? Okay, how many workers do I need? I'm getting there, but we want this to be with the GPUs. We want this to go even faster. So let's go get a GPU cluster next. And I'll kind of wrap up my code examples here with the GPU cluster. So very similar, again, I'm going to use coiled, but you could do this with a bunch of other approaches, and Rapids does document how to set all of this up. And now with a GPU cluster, I have 4 workers. Each of them have the T4 GPU, which is so nice. And now we can really make this thing saying, when we execute this code, this will execute in about 13 seconds. So let me run this jump over. Hopefully it isn't finished by the time I get there, because it's going really, really fast. And you can see on the GPU, this is going to execute much, much more quickly. These are those same tasks. They're just flying through. And in the Dask dashboard, there's a ton we can do here to zoom in and try to better understand. We got to zoom in even further. Oh my goodness. To zoom in on as to actually what is taking what amount of time. This is a whole kind of talk in itself, but we'll be able to see, and I should zoom in further to show you exactly which steps you can see the time here. So I want to pause there for a second, and I'm going to take a quick look at the chat. But what we've shown is we've taken this same workflow. We started with running on our local machine, or running locally using pandas. We realized we hit a memory error. Same thing, we used our GPU. Gosh, the GPU is so fast, but to get the full data set, we needed to get around a local memory bottleneck. Installing Dask and running Dask, running Dask on a local Dask cluster helped us get around this. It was a little bit slower than maybe I personally would have liked, but I solved this. I'm now using Rapids, I'm using a GPU, I'm doing it with a pandas-like data frame. This is very similar syntax, read CSV, group by. I don't have to learn a new API, and I'm able to process this data. I'm able to get a big performance speed up. This is very, very exciting for me. I like this. This is probably where you could stop. If you want additional performance, if you want to go even faster, you can distribute this out, exact same syntax with Dask, onto a cluster. We could do this on a CPU cluster, and it ran at about 1:30, 1:20, very similar code, read the CSV, group by, and we could go even faster on a GPU cluster. And again, the important thing here is our code doesn't change. Whether it's local cluster or distributed, it's the exact same thing. It's just this Dask code, Dask UDF, read CSV. So if you haven't checked out like Ben Zeitlin's talk or all the stuff that the NVIDIA folks have been doing here, you really should. But hopefully this is like motivating enough. Hey, I can use a little bit of Numba to compile my Python, especially for loops, NumPy stuff, broadcast functions. Do that. If you have data frames, you really want to look at Rapids QDF, and you can use Dask to distribute that across clusters. Let's talk a little bit now about how this all gets installed and how all this gets set up. So I will show that here, and I'm going to try to wrap this up. Maybe, I guess, since I have an extra minute or two, I'm going to wrap this up in the next 5 minutes. So real quick on setup is, and I'll just show it directly from the different cloud tools. To use Rapids, they have this wonderful guide, and they'll explain where you can get things and how to set things up in the cloud. And this isn't specific to the company I work for or anything like that. It's just for AWS, Azure, GCP. What I've found to be the easiest approach per cloud is to use their hosted ML service. So if you go into SageMaker, you can create notebook instances and jump directly into Jupyter Lab. And here I just created a G4DN XL. So this is about 75 cents an hour. It's 4 cores, 1 T4. I don't pay for a very expensive instance here because I'm going to use something else, coiled, to scale out when I need clusters of GPU workers or clusters of CPU workers. This helps me keep my costs down. But in this case, I create this notebook instance. And then when I'm inside of Jupyter Lab here, it's very easy to get everything installed because Rapids gives us this quick start, which is really, really impressive. So I click over here on Get Started, and they give you this little release guide. And so this is exactly what I follow. And you can choose between what version you want, what version of Python, what version of CUDA. And what's nice about SageMaker here in this case is they give us all of the things that we need. So if you try to install this yourself, which you could if you had a local GPU, but you'll need to install CUDA. This comes pre-installed. You just don't have to worry about it. So intentionally like not giving details here because it's just like this becomes a solved problem. GCP has a very similar offering. This is called Vertex AI. They keep changing the name. It looks like it's about half the price of SageMaker, which I find very nice. And I create the same instance, 4 cores, 15 gigs of RAM, and then it's in Jupyter Lab once again. And then we're just copying and pasting this example. And then finally, in terms of getting things installed, so hopefully this is like, hey, if I can run one conda command, I can get everything installed. This Rapids package includes Dask, it includes Numba, it includes all of this stuff. You could also just pip install them directly, but it can get a little bit tricky. This is where I should have prefaced at the beginning. This is really where Rapids as a package shines. It gives you cuDF, it gives you all of this stuff. All of it works. Finally, if you want to do this on your clusters, Docker is a great tool for this. You don't have to learn Docker. They will give you this Docker command, a pre-built container image. And then what I did with Coiled here, just for completeness, when I created these clusters, I specified what image I wanted to use. There's a facility within Coiled for doing this. That's a Docker image, but this also works for other tools for deploying Dask, and I'll talk about that here in a second. But so basically, for getting set up locally, it's use Rapids, and it's going to be very straightforward. Then we got a great question in the chat, which is like, hey, can I use Numba JIT? Can I use Numba with Dask? And the answer is yes, absolutely. So that will be this should be my concluding example here. So I've got let's just restart this. Yes, you can combine them. And the reason I spent more time on cuDF than on working with Numba, and I apologize if that led some folks astray from my agenda, was I was kind of blown away by just the completeness with cuDF, how easy it is to get started, and how when you use Dask, you can scale this out very nicely. Numba, when we're going to run on the GPU, is going to involve a slightly different API than running on the CPU. And that was a change. I don't know how recently this change occurred, but from a previous version of this code that I'd run with like Numba, like 0.48, it didn't involve this API change. And I'll be honest, it kind of walloped me in the head. So, but yes, our code will run here. This will work. And sorry, I have to make sure I have the right cluster. Let's get that existing Gus CPU example v2. All right, let's get our client object. And I may not have enough time here to show this, but the short answer is yes, it can. And so in this case, I have that same Numba JIT, that same code. We've wrapped our existing code with Numba, and then we can submit it to our Dask cluster. And here, previously, you just saw like Dask cuDF, you just saw Dask data frame. It was a pandas-like thing. Here we're using the lower level interface that I mentioned at the very beginning when I introduced Dask. This is Dask futures interface. It's very similar to Python 3's concurrent futures. And so now I can submit arbitrary tasks, and tasks, I can submit each of these functions. And in so doing, I can now start to see linear speed up here. So we can take that compiled code, we can send it to the scheduler, we can send it across our workers, and we can see linear speedups across our Dask cluster. So yes, this does work very, very well. And this also works, Numba is absolutely compatible with CUDA, with running on the GPUs. There's just a slight adjustment in terms of setting some initial variables that has me, as a very basic beginner type user, as somebody who was walking into a server room versus using an SSH client, a little bit stymied at the moment. Okay. All right, so let's wrap this. Let me wrap this up with deployment options, and I'll jump back and show this from slides just to keep this a little bit cleaner. So in wrapping this up, you can deploy Dask a bunch of different ways. Dask can be installed manually. There's excellent documentation. I have links to all of this. It's just a CLI command. There is a tool for running Dask on your cloud provider, AWS, Azure, GCP, and a few others. This tool is called Dask Cloud Provider. It's open source. You can go ahead and use it. You can also deploy Dask on Kubernetes. And so if you had a cluster of machines, you could now say, great, if I've got a cluster of GPU workers, I can use Dask Kubernetes. I could use Dask Cloud Provider. I need to use an image or two from Rapids to make sure I have my dependencies, but that's your pattern. There are also commercial offerings, 3 in particular, Coiled, where I work in sales. Saturn Cloud also offers, they're very much a competitor. They offer Dask clusters as a service, hassle-free Dask clusters. And then in terms of the major cloud offerings, there isn't a AWS or Azure Dask offering yet, but Google Dataproc, which is, Google Dataproc, which is their Spark cluster as a service, uses an open source Dask package called Dask Yarn to deploy Dask. Your mileage may vary with that, but it is an option. Obviously, I'm heavily biased towards Coiled because I work there. A quick recap on costs, and then I think I'll wrap this up, as I know I keep saying I will. So I'm running the client. So you saw SageMaker, you saw Google Cloud. You would see Azure, but I'm getting some quota issues, and it's just a little too expensive, I think, for this for the budget I was trying to set for this. So here are the costs factoring in the clusters I got from Coiled. This case, 38 cents for the hour of my GCP notebook, and then 81 cents for my GPU cluster. And then similarly for AWS, 75 cents for an hour of my SageMaker notebook, and 81 cents for my GPU cluster, about half the cost, excuse me, for the CPU cluster. So the nice thing here, again, however you choose to deploy ephemeral Dask clusters, if you're running these in the cloud, we'd highly encourage you only run them when you actually are executing your code, when you're thinking about things, when you're sipping coffee, when you're hanging out and just mulling over your problem. Use a much less expensive client. Oh, and before I'm going to skip comparisons actually and say the final bit of this that's I think that's exciting is a relatively recent Python package Eric Welch and James Bourbeau just recently put out. And this is a tool called Afar. So if you don't want to use a GPU client, if you don't have a GPU on your local machine, if you don't want to install Rapids on your local machine, if you don't want to bother setting up a SageMaker notebook, a GCP notebook, or an Azure ML compute instance, you actually can run all of these things from a local machine thanks to this new package called Afar. This is really, really cool. It's very new. So it's still, for me personally, I still tend to use one of these GPU clients to make things easier. But all I have to do now to have here back on my local machine, localhost, I can import Afar, and with this little with statement, I can now I can run remotely, submit this code to my Dask cluster. We'll come back over. You can see this on the GPU example. This code is going to be executing here on my GPU cluster. And I'm doing this from a local machine where I don't have a GPU on my MacBook. I don't have CUDA installed. I don't have to worry about those dependencies. I can work with a Dask cluster Afar. So big thank you to Eric, big thank you to James. We'll be looking for more from this package. Again, I think you'll probably still find it useful to have some local GPU client. It may even save you money if you have smaller data sets or if those longer times are acceptable. But now you could say, okay, hey, I could use a remote cluster from somebody like Coiled or Saturn Cloud or something else, or Dask Cloud provider, and I can work from my local machine directly with that cluster without having to set up this intermediate client. Okay, so there, I will pause now. I'll stop sharing. I hope we're not I'm 20 minutes over. My apologies. There are a bunch of great tutorials on Dask on them. Yeah. I don't think there are any other questions in the chat. Thank you all for listening and for showing up.